CO6, which is the last objective in our unit. We've done all the things, the listing method, the table method, practice with just numbers. The one thing left to tackle would be, of course, word problems, okay? And if you remember back to greatest common factor, there were a few phrases, few words within the greatest common factor questions that told you this is greatest common factor. Who remembers what those are? What did you see? What did you read in a word problem that told you this is the greatest common factor type situation? We underlined these phrases, these words in every word problem question we had. Well, the nice part about this all being one document is we can go back and look. Okay? Here was our greatest common factor word problem page. What phrases, what words did we say stand out? Yeah. Identical. What else? Okay, so identical is one. What was the other phrase? Using all the items. Right? Identical and using all the items. Well, it turns out least common multiple has some phrases also. That tells you this is a least common multiple type situation. Let's read the first one. Pat, Mark, and Chris take off from the starting line on a racetrack at the same time. Pat can run a lap in 2 minutes, Mark can run a lap in 5, and Chris can run a lap in 7 minutes. How long will it be until they are all together at the starting line of the track once again? Marina, put that way. Okay. Let's go to the second one. See if you can draw any comparisons here. 4 ants leave their hill together at 5 a.m. All 4 return and then leave again in the following manner. The first ant every 4 hours, the second every 2, the third every 3 hours, and the fourth every 4 hours. At what time will all 4 ants be at the hill together again? 2 stoplights, both turn green at 1:05 p.m. It takes 1 stoplight 20 seconds to complete a cycle, which means go from green to yellow to red and back to green again. And it takes the other stoplight 36 seconds. At what time will both stoplights again turn green together? What are you noticing is kind of similar between all of these questions? What verbiage? What are you being asked? What similarities can you draw from this? Callie, go ahead.
It's like saying like when will they all be like back together again?
Yeah, okay. So in all of these, it's saying when are they all together? When will the ants be all together? When will the stoplights turn green together? Okay? So in a least common multiple question, you're looking for when something is going to happen again. Notice how they all start too. Pat, Mark, and Chris all take off from a racetrack at the same time. 4 ants leave their hill together. 2 stoplights, both turn green, right? For least common multiple, something is happening. When will that happen again? That's kind of your clue to least common multiple question. Something happens, when will it happen again? Okay? So, that in mind, let's start with Pat, Mark, and Chris. Okay? They're all leaving, they're all starting, running around this racetrack at the same time. Pat's the fastest. He can run a lap in just 2 minutes. Mark is more of a jogger, takes him 5. And Chris takes his time. He runs a lap in 7 minutes, right? How long will it be until they are together at the starting line of the racetrack once again? So let's just do the listing method here. We got Pat, okay? Pat starts. He will again be at the starting line 2 minutes later. He'll again be at the starting line 2 minutes later, which would be 4, right? Takes him 2 minutes to run around again. 6. And then 8, and then 10, and then 12, and then 14, right? Notice what we're doing here. We're skip counting by 2s, which is what we did with the least common multiple method on the first page, okay? Mark, he will be back at the starting line 5 minutes after he begins. And then what? 10. And then 15, and then 20, and then 25, and then 30, and then 35, okay? Chris, it takes him 7, so he'll be back at 7, and then 14, which I see a match with Pat and Chris. So 14 minutes after these 3 start, Pat and Chris will be at the starting line together again, right? Pat will have run 7 laps by that time, Chris only 2, but they'll be there together again. Will Mark be there? No, he won't be there till 15 minutes, right? So 14 is not going to work for all 3 of them. But then Chris again at 21, 28, 35. So 35 minutes later, after they start, Mark and Chris will be together again. We're not out to 35 for Pat, but will he be there?
No.
How do we know that he won't be?
Because it's an odd number.
Because 35 is odd, right? And if we're counting by twos, we'll go 34, 36, but we're not going to hit 35. So maybe the listing method is not quite the right way to go here. Let's just pause that and let's table this, okay? We've got 2, we've got 5, we've got 7. Anything we can take out of those 3 numbers? 2, 5, and 7?
1.
Yeah, 1, right? So, what do?
Multiply those.
We take the L, even though it's not really a L to take here, okay? Oh, it's like a shoe, like a running shoe. That's perfect. But we do multiply 1 by 2 by 5 by 7, and what do we get? Somebody with a quick maths here. 70. So had we continued the listing method, we would have to go all the way out to 70, which would take a while for the 2's, just because it's a lot of 2's that go into 70. So here the table method much more efficient, but you can see, kind of how this is laying out here. Okay, so 70 minutes after they start, they'll all be back at the starting line together again. Okay, does that make sense? Why this is least common multiple? Because we're looking at when something's going to happen in the future. That's kind of how multiples are, right?
Yes.
They tell you what's going to happen. You skip count by 2's, you're kind of going to the future. What are we doing? Push your arm on your own. Live. Bubbles.
Exactly.
Scoot over, you got all that space. Next one, 4 ants leave their hill together at 5 a.m. Something happened, right? We want to know when that will happen again. All 4 return and then leave again in the following manner. The first ant is busy. The first ant comes back every hour, right? So if they leave at 5 a.m., this ant will come back 1 hour later. We'll be back 2 hours after 5 a.m., 3 hours after 5 a.m., 4 hours after 5 a.m., and so on, right? Every hour, the ant returns. The second ant comes back every 2 hours. So leaves at 5 a.m., we'll be back 2 hours later, and then 2 hours after that, total of 4. 2 hours after that, total of 6. 2 hours later, and 2 hours later. Okay? So the first and second ant will be back together at the hill 2 hours after they leave, which is what time? If they leave at 5 a.m., they're both back 2 hours later. What time would it be? 7 a.m. They're both back 4 hours after they leave, which would be what time? 9 a.m., right? Okay. The third ant, kind of over here, comes back every 3 hours. So the third ant will return 3 hours later. And then 3 hours after that, total of 6. 3 hours after that, total of 9. 3 hours after that, total of 12. And so on. The fourth ant comes back every 4 hours. So after the fourth ant leaves, they'll come back 4 hours later. Then 4 hours after that, total of 8. 4 hours after that, total of 12, and etc. Can anyone kind of see where we're headed here and tell me what the LCM, the least common multiple, is going to be if we continue this skip counting pattern, Melanie? It's going to be 12, right? This one, it just comes back every hour, right? So everything's a multiple. And then 2, we're almost there. The first number that shows up in each list, and if we, eventually we'll get to 12 here also. 12 is the least common multiple. Okay, which means that, if we look at the question, at what time will all 4 ants be at the hill again if they come back 12 hours later, which is what that 12 represents? It doesn't represent 12 noon or 12 midnight. It's 12 hours later. What time would that be?
5 p.m.
5 p.m. Okay? 5 p.m. Or, if you are a military time person, that would be 1700 hours. Okay? Do you know how military time works?
Yeah.
How?
How?
Yeah, like,
So they work on a 24-hour clock, like they don't start over at 1 p.m., you know? And so every hour after 12 noon, they just keep counting up until they get to 24. So if you're at 1700 hours, that's 5 hours past 12, so it'd be 5 p.m. is how that works.
That makes so much more sense than like.
It does. It's meant to, you know, if you're communicating, especially back when communication was, you know, not incredibly reliable, if over the radio or whatever you heard 8, but the AM or the PM got staticked out, and that's when you were supposed to launch or whatever else, it'd be a lot confusing, right? But if you hear 2000 hours, there's only one time 2000 hours can be, and that would be 8 p.m. Yes?
But like, if you're listening to the radio and it says 8 o'clock, if it's nighttime, you know if it would be PM, but if it's
Or if you're talking
morning-
about the next day.
Oh, true.
Okay, 2 stoplights, both turn green at 1:05 p.m. It takes 1 stoplight 20 seconds to complete a cycle, and it takes the other stoplight 36 seconds to complete a cycle. And the question is, at what time, so similar to the one previous here, at what time will both stoplights again turn green together? So something is happening, they both turn green at 1:05 p.m., something is happening again. Go ahead and find the least common multiple of 20 and 36. Do it on your own sum, 20 and 36.
Take the teacher. I didn't.
Anyone still need these notes? Or are we good here? What?
I'm good.
You good? Oh, good. You're, yeah. Oh, too late. Okay, so for this one, if you wanted the listing method, you could. I'm gonna do the table method, just because we haven't really practiced that much today. So you got your 20, you got your 36, okay? And what can you take out of 20 and 36? Get us started, Layla. 2. They're both even, so you can start with that. Divide by 2, divide by 2. That gives you 10 and 18. What can you take out of 10 and 18? Ava?
2.
2 again. They're both even again. So let's just keep doing that until we can't anymore. So I'm making a line. Out comes a 2. Divide by 2, divide by 2. And we get 5 and 9. Okay? What can we take out of both 5 and 9?
1.
just a 1. Nothing can come out of both of them. So we're at that point where you take out a 1, which means you're done. And then you take the L. Right, Liv?
Yeah.
Take the L for least common multiple. Okay, you're multiplying all of these things together, which is 2 times 1, which doesn't change anything, but might as well put it in there. Times 5 times 9, what do we get from that?
180.
Lauren? 180. Okay? What does that 180 mean? Read the question here. What does the 180 mean? Melanie?
3 minutes.
And how'd you get that?
Because 180 divided by 60 is 30.
Okay, so our unit here is seconds, right? 20 seconds, 36 seconds. That means our LCM, that 180, is in terms of seconds. It'll take 180 seconds for these lights to again turn green. And then Melanie divided that by 60 because there are 60 seconds in a minute, and she came up with 3 minutes. It'll take 3 minutes until these stoplights again turn green. The question is, at what time? Right? 3 minutes is a length of time, but it's not a time. So what would your final answer here be, Marina? 1:08 p.m. Okay? Your final answer is 1:08, or in military time, 13:08. Okay? 1:08 p.m. or 13:08. How are we doing?
Good.
Decent? Okay. Mr. Schultz eats tacos every 4th day and buffalo wings every 9th day. Every so often it happens that I eat tacos and buffalo wings on the same day, and I call those buffalaco days. They're my favorite. Approximately how many times a year do I have a buffalaco day, where I have both buffalo wings and tacos on the same day? And then, why would it be foolish of me to ask you to find the least common factor of 2 numbers? Okay? And then, likewise, why would it be foolish to ask for the greatest common multiple of 2 numbers? So think about what factors are. Why would I not ever ask you for the least common factor of 2 numbers? And then think about what multiples are. Why would it be foolish for me to ask you for the greatest common multiple? Kind of working with those definitions. Okay? And then, is that the end? That's not the end. Review! What is the GCF of 24 and 80? That's from PO4. And then CO5, solving the proportion. It's set up for you. You just need to use those equivalent fractions. So this is your homework for tomorrow. These 5 questions. We will get the test for funsies tomorrow, and then your test for realsies will be on Thursday. Questions, comments, concerns, complaints, compliments, congratulations, criticisms. A little hint on the Buffalaco Day question. At the very least, you know you're finding the LCM of 4 and 9. Right? Those kind of the numbers there. It's the least common multiple section, so it makes sense. Then, what do you do with that? That's the challenge here. It's finding the LCM, yes, but then applying it to the question. If this would represent how often I have a Buffalaco Day, the LCM of 4 and 9, and the question is approximately how many times a year does that happen? So it's finding the LCM, but then going one step further with that. And then the word problems and the time for review. All right. Anything else? You have about 12 minutes to work on it. Very good. With gusto. That's how you math.
And don't forget to like and subscribe.